Hello everyone, my name is Andrei Costinescu, and together with Darius Burschka, we welcome you to this video presentation on how to perform context analysis in static household environments. The two pictures on the slide depict the same amount and the same type of objects. However, the context that they form is very different. The left image being an example of a lecture arrangement, while the right image shows a circular meeting arrangement. Therefore, there is something other than the objects in the scene that differentiates a context. Being able to determine the context of a static scene is important for human-robot interaction and collaboration, and can be used, for example, in service robotics to clean up or prepare environments. As seen on the previous slide, simple object presence is not sufficient to determine the semantics or the meaning of a scene. The relations between the scene objects are the ones that determine the scene's context. When presented with a disordered scene, our system is able to determine the most probable context of the scene. And once we know the most probable context, we can also determine which objects must be added, removed, and repositioned in the original scene for it to be transformed into the most probable context. In this presentation, we will focus on the scene representation that enables us to perform the previously described classification and transformation tasks. The parsing pipeline of a scene is as follows. An object detector lists the objects and their poses in the scene. These are then processed by our scene parser, which outputs a relation graph. This is our machine understandable scene representation. Our parsing strategy is based on the observation that scene arrangements are built hierarchically, with some objects being more important than others in this hierarchy. These objects are then called reference objects, and they are more important than others in the sense that reference objects influence the pose of other objects in their interaction volume to form a context. An object's interaction volume is the space around it in which the pose of other objects can be influenced to form a context. For example, in the left image, the table is a reference object. All chairs are in the table's interaction volume, and the table influences the pose of the chairs such that all objects form a meeting context. In the right image, the central viewpoint of the chairs is the virtual reference object of the scene. Virtual because it is not a physical object in the scene like the table in the left scene. Reference objects guide the scene parsing, as only those parts of the scene that have a reference object will be analyzed in more detail. After parsing the list of objects and their poses in the scene, the relation graph contains all the objects, surfaces, and groups found by the parser. Group centers point to a reference object. For example, the floor surface is the group center of a group contact surface, GCS1, because the tables and the chair's bottom surfaces are in contact with the floor surface. Similarly, the table is a reference object because it is faced by the chair, forming a group facing object, and because the bowl's bottom surface is in contact with the tabletop surface, forming another group contact surface. The floor, the table, and the bowl are the scene's reference objects, and together with the chair, they form the reference object hierarchy of the scene. The reference object hierarchy contains the red and black nodes in the relation graph, and this is the basis for scene classification and transformation. The reference object hierarchy of the learned context is used to add, remove, and change objects in the original scene to transform it into a desired version, for example, to clean up a very messy scene. In this example, we must add 2 cups, a bowl, and a chair to transform the first hierarchy into the second. The object surfaces and the groups contained in the relation graph have the necessary semantic information about how and where to place these new objects. Thank you for your attention, and stay tuned for questions and more updates on the topic.